Hey everyone, this is Dr. Mahmoud Al-Odeh. I'm here with you today to explain Chapter 9, Economic Life Service and Replacement Analysis. Let's go ahead and start. We'll go over some background information, terminologies, and then we'll get into some examples. All right. So for this chapter, what you will be learning after finishing this chapter, you will be able to discuss concepts and terminologies regarding replacement alternatives. You will be able to calculate the economic service life for an asset. You will be able to conduct analysis in order to make decisions regarding the timing on when to replace and the currently in place alternatives with a defined time. Number 4, we will compare new alternatives with current alternatives and select alternative that is economically justified when having undefined time. And number 5, we will be able to determine the replacement value of current in-place assets compared to a new alternatives. All right, let's go ahead and start. So as you know, after a long time period, or after some time, companies, managers will need to make decisions on replacing current assets. And they sometimes, they spend a lot of money on these assets, but they don't want really exactly to replace it until they make sure that there is a benefit of it. So these kind of decisions sometimes is difficult. So in this chapter will help you to gain the skills that you need to make these kind of decisions. Before we go ahead and talk about the replacement study and how we could conduct a replacement study, let's take a look into these terminologies. We will be using a term called defender, and the defender, it's the currently in used assets, the in-place assets. So whenever we say defender, that means the in-place assets. Number 2 terminology that we will be using in this chapter is called the challenger. The challenger is a term for a new alternative that it's proposed to replace the in-place asset, the current assets. Economic service life, or ESL, is the expected number of years at which the lowest annual worth of cost will occur. All right, so what is the economic service life? So if you look into this graph right here, all right, this graph basically will show you the blue one is the asset value. As you see, the value of a machine, a car, and an equipment, anything you called asset, it will decrease by time. So it was right here, it was like 300,000 on year 1, and then will decrease all the way to 50,000 on year 25. So number 1 is the value of the asset will decrease. The longer you keep the asset, you will have to maintain it. So you start with the minimum maintenance and operational cost at the beginning of their lifetime, and then they will reach a point where you will pay a lot of money to service that asset. So if we put these together, if we put the asset value and the maintenance and operational cost, what's going to happen? We will create this gray line. The gray line will show you what would be the cost for that asset, and you will see that number is decrease until one point, which is right there, that has the lowest point, and that would be year 9. All right, and then we'll start decrease all the way going up, and in this case it would make sense to replace that asset on year 9. So if we look into this table right here on the right side, and I want you to ignore the value of assets and the maintenance and operational costs for just this example. Look at the total annual cost. You will see that the total annual cost start with 300,000 and then start to decrease until year 9. Year 9 is decreased, and then later on start to increase. So what would be the time to replace this asset would be the year 9. So whenever you see the annual cost is decreasing, 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 and there's a one point that will flip that chart and will increase the cost, that would be the ESL. This is where you have to replace the asset. All right, what we need to know, we need to look into different parameters and factors in every example. So let's take this basic example, which it's not in my book yet. So I came up with it recently, and this will be added to my book in the future editions. All right, here's the example, a forklift, and this is the Defender. Just keep in mind, this is the in-place asset. The forklift purchased 2 years ago for $50,000. It is hard to maintain than expected. So the thing was easy, but it's hard to maintain and as expected. It can be sold now for $15,000 or kept for a maximum of 2 more years. So whether they sold it right now for $15,000 or they could keep it for 2 more years. The maintenance and operational costs would be $20,000 each year with a salvage value of $10,000 after 1 year or $9,000 after 2 years. Another alternative that would be the Challenger, having a different, to sign a contract for $25,000 per year at interest rate 10% per year, and over a study of period of 2 years, determine the value of P, N, A, and S for both Defender and the Challenger. All right, let's take a look into the Defender here. If we're going to replace it right now, the P would be 50,000, N would be 2,000, salvage value would be 15,000, the A, the annual maintenance and operational cost would be 20,000. These parameters will help you to find out what would be the annual cost for this asset, and then we will calculate the total cost in order to. So in any example, what you will do, you will calculate the annual worth of an assets, and then find what would be the lowest annual worth of course. We will come back to this steps, but here what I want you to do, I want you to be able to identify P, S, A, and N. So if we said we need to keep this asset for 1 more year, the present value is still 50,000. Number of years would be 3 years. The salvage value 10 years if we replace it on year 3, which is a 1 year from now. And then the annual worth was still 20,000. If we need to keep it for 2 more years, that would keep the 50,000 as is, that's the initial cost, and equal 4 years. Salvage value would be 9,000 because we were going to sell it 2 years from now. And the A would be $20,000. The Challenger is only one number, which is 25,000. It's a contract, so that's the only number we have for the Challenger. So with this example, I want you just to be able to identify what the different parameters that we will be using. And as you see, these the values of P is still constant, the same thing. The number of years on when we're going to replace this asset, are we going to keep it for 2 years, 3 years, or 4 years? That will change. The salvage value, which is what we're going to refer to in this chapter called the market value. All right, that would be decrease over time. So if we're going to replace it in 2 years from now, that would be 15,000. If we need to replace it 3 years from now, that would be 10,000. If we need to replace it 4 years from now, that would be 9,000. The annual maintenance operational cost in this example is $20,000. But however, as I mentioned earlier in the previous example, the chart where we see the increase of the maintenance and operational cost, and we will consider that. But in this example, it's $20,000 and constant, and we'll keep it. So now, what we need to do in order to calculate the economic service life, the ESL analysis. The ESL analysis, you need 5 steps for this. Number 1 is to look into the initial cost. So we need to look into the initial cost, and we need to find out what would be initial cost. It is present value, right, in a P format. What would be the equivalent of the initial cost if we need to replace it in 1 year, 2 years, 3 years, 4 years, etc. And then we put that in a cell. And it depends on how long we need to keep this asset. Number two, look at the market value. Again, the market value is the salvage value, but we call the market value how much you can get back from your asset if you sell it right now. So what we need to do, the market value, it's a salvage value and it's a future value. So what we need to do, we need to find out what would be the annual worth of the salvage value if we kept the asset for 1 year, 2 years, 3 years, or n years. And of course, the function to use to find the annual worth would be the PMT, with the difference between where to put the present and the future. So in the first step, we put the initial cost in the P parameter. And for the second step would be we put the future, we'll put the salvage value or the market value in the future parameter. We'll take examples and I'll show you. So we found the annual worth for the initial cost. We found the annual worth for the market value or the salvage value. And then three, we find the annual worth for the total, the annual worth for maintenance and operational cost. That's number three, is to find out what would be the maintenance and operational cost over the years. And then add these together. Number 1, 2, and 3, add these, the initial cost, the equivalency for the initial cost, the equivalency for the salvage value, and the equivalency for the maintenance and operational cost, which is sometimes it's given to you in the annual, most of the time given to you by the annual worth. So you add these together and then find what would be the lowest cost, and that would be the ESL. All right, let's go in this example. And again, this is an example, new example that I just added. I'm going to switch to Excel for this example. So you will see exactly what I'm doing here on Excel. All right. For this example, we have a 3-year-old heavy-duty power system is being considered for early replacement. All right. Its current market value is $20,000. Estimated future market values and annual and operational costs for the next 5 years are given in the table here. What is the economic service life for this Defender if the interest rate is 10%? All right, so we have the market value to be $20,000 right now, and we have been given the market value for the next 5 years. Year 1 will be 10,000, year 2, 8,000, year 3 is 6,000, year 4 is 2,000, and 0 for year 5. The maintenance and operational cost for this, 5,000 on year 1, 6,500, 8,000, 6,500, and 12,500 on year 5. All right, so what we need to do, we need to add these 3 numbers: the initial cost, the salvage value, which is the market value, and the maintenance and operational cost. These are 3 numbers that you need to use in any replacement study. Let's go ahead and start with and of course, all these numbers should have the same time frame. All should be in the A format. All right, let's go ahead and find what would be the annual worth for the market value. All right, so the market value, the annual worth for the market value equal PMT 10%. And we selected the year 1, and I selected 1 here because I want to copy the cell, would be helping me to save some time. And then again, the market value is in future, so that would be the future value parameter. FV would be the 10,000. Now move on to the next one. We PMT 10%. We are on year 2. We're going to keep this for 2 years, and then the same thing, we need to keep this for 3 years. And what would be the equivalency for the market value if we need to keep it for 3 years? And that would be what would be the result. And now what would be the market value if we need to keep this asset for 4 years? And what would be the market value if we need to keep it, what the equivalency of the market value if we need to keep it for 5 years? So again, what we did, this is given. This is given. All right, this is given. Double check on this. All right, here we go. So this is given. The same thing. This is the maintenance and operational loss cost is given. This is calculated. And the same thing, this is calculated, and this is calculated as well. All right, so what we have here, so we did calculate the annual worth of the market value. This is given to us, and this is in the A format. We don't have to do anything. Now, for the initial cost, what we need to do, we need to find out what would be the annual worth if we need to keep this asset for 1 year, if we need to keep this asset for 2 years, 3 years, 4 years, and 5 years. All right, so we did this for each one of the years. So what we have a table with 5 years cash flow starting from year 0 to 5, and we did have this market value. And again, I'm going to put that in parentheses. This is also called the salvage. This is also the salvage. In previous chapter, we called salvage value. So for example, if we need to sell this asset after 1 year, you can get a $10,000 for this asset. If you said, no, I'm going to keep it for 2 years, you will get $8,000. All right, so now let's do the calculation. We need to find out when would be the best time to sell this and replace it. Total cost for, if we need to keep it for 1 year, would be adding the annual worth of the market value, the maintenance and operational cost for 1 year, and the annual worth of the initial cost. That would give you $17,000. Now, if you said, okay, well, let's think about it. We maybe need to keep it for 2 years, not 4 years. So we need to find out what would be the annual worth of this asset for 2 years. And that would be finding the market value for 2 years, which is 8,000, annual and operational cost 6,500, and find out what would be the annual worth of the present of the $20,000, which is the initial cost, which is 10%. We're going to keep it for 2 years, and the 20,000, it's a present value. And the same thing, we said, all right, well, we're going to keep this for 3 years. So what would be the equivalency for the initial cost? All right, so we did this, all of these, we did the calculation, and we found what would be the total cost. And now let's take a look into the numbers here. That's 17,000, 14,214, 14,229, 15,000. And now we need the point that where the chart will flip. Instead of going down, we need, where is that point that will flip the chart and the cost will start increasing? So on year 1, 17,000. Year 2 is 14,000. It's decreased. Year 3 is 14,200. Now that's where is the point. It starts to increase, and then 15,000, 17,000. So between year 1 and 2 here, you will see that the value is increasing from 214 to 229. So that's the point. That's the end of the curve where the cost will start seeing increase. So the ESL, the economic service life for this asset would be 2 years. So on 2 years, this asset should be replaced, and this asset should be replaced, because if we're going to keep it for longer, that's basically will cost us more money. That will cost the company more money, and it would be perfect to be replaced on year 2. All right, so I hope this is helpful. Now we're going to move to another example, but I'm going to record another video. So I'm going to stop the video here, and I'm going to record another video on a different example, and we will continue with this chapter. I'll see you in another video.